let's go to page 153 and let's start with number 167. It's number 167. You have this picture over here. So you have A, M, D, C. Okay, so it says in triangle ADC, the segment DM is drawn such that angle ADM is equal to angle ACD. Okay, and you want to prove that AD squared is equal to AM times AC. Okay, so what you want to do first is that sometimes it's kind of harder to visualize, so it probably helps if you separate the two triangles. Okay, so you have the ADC, and then you have the A, D, A, and D. Okay. So what you need to do is go and match this. And so notice that angle A and angle A are congruent, right? Because it's reflexive. So now you can see the triangle. So you have to match up things carefully. So you got A, C, D is similar to triangle. So A match with the A. Okay, C, the one hash mark, match with the D. And no marking match with the no marking. So D match with M. Okay. So once you have a similar triangle, then you can go and do the proportions. So you can have the AD. You can have the AD over AC is equal to, so AD is the one that facing the one hash. So the one facing the one hash is AM. Over AC is the one facing no markings. So it'd be the one facing no marking would be AD. Okay. Okay, so you can AD over AC will equal to AM over AD. So matching up things carefully, or you can see it from here. AD match with AM, AD match with AM, AC match with AD. Then after that, you're going cross multiply. So you got AD squared equal to AM times AC. And that's what we need to prove. Okay. Okay, let's go to number 168. Okay, it says how many scaling triangles have all sides of integral length and perimeter. So perimeter is less than 13. That means the biggest number you can have is 12, right? And it's a scaling triangle, means all sides are different. So how many different ways can you have? Okay, so in this case, again, the biggest side the longest side you can have is 5. Okay, because if you have a one side 6. Then the other side will sum up equal to 6, and you will have a degenerate triangle. So you can have a 6. Okay, you can have anything 6 or more. So the longest side you can have is 5 with a perimeter of 12. Okay. So if one side is 5, then you have 7 left over for the other two sides. Okay, so your combination would be 3 and 4. Okay, because you cannot have 5, 5, 2 because they will give you isosceles, right? Because this is a scaling triangle, means all three sides are different. So one possibility is 5, 4, 3. Another possibility is 5, 4, 2. Now you cannot have a 5, 4, 1 because the 5 cannot equal to the other two sides, right? Because that way you're going to end up with a degenerate triangle. Okay, so 5, 4, 2, and that's it. Okay. So that's all the possibility for the 5 as the longer side. Now if you go down to the 4, Okay, so if it's 4, then you have 8 for the other two sides. So you can have 4, 4, 4, which give you equilateral triangle, so cannot, right? So again, if the longer side is 4, the next number, you cannot have a 4. So you cannot, again, it's scaling. So you cannot have a 4. So you can only have 3. So, and you can have a 3, right? Because you give you isosceles, right? So you can have 4, 3, 2. And after, you cannot have 4, 3, 1 because 4, 3, 1 is no good because they will give you degenerate triangle, right? And you can have 4, 2, 2, and so that's it. Now, once you go down to 3, again, you can only have 3, 2, 1, and again, this is no good, degenerate, right? Again, scaling means all three sides have to be different. Okay, so by just trying all the combination, then there are only 3 possibilities. Okay, let's go to 169. Okay, it says the size of a triangle BAC. Okay, so draw a big triangle. So BAC, and they're in a ratio of 2, 3, 4. Okay, so again, it doesn't matter. So I'm just going to put 2x, 3x, 4x. Those are a ratio 2, 3, 4. And it says the BD is an angle bisector drawn to the shorter side AC. So this is the shorter side. So angle bisector is drawn to that side. Okay. And I'm going to call this D. And shorter side AC and divide into segment AD and CD. So you got AD and CD. Now, if the length of AC is 10, so if this is 10, so that means this would be a 5, 5, right? Okay. So that means that if you notice the 2x is 10, so x is 5. So that means this will equal to 15, this is equal to 20. Okay. Then after that, then you find the length of the longest segment of AC. Okay, so I take that back. Okay, let's see, double check. Yeah, so this is an angle bisector, so that's not going to be equal. So just be careful with that. So, but we know this is 10 now, 10, 15, and 20. Okay, so I'm going to turn the triangle the other way, so easier to see. Okay, so this is a BCAD angle bisector. Okay, so this is 10, and this is 15 and 20. Yeah, so be careful. These two are not going to be equal. Okay, only if this is the median. The angle bisect the angle, but because this can be because this is not isosceles or equilateral triangle, so this is not going to be equal. Okay, so from here, we're looking for the segment. So I'm going to label this x and this is y. So from here, okay, we can write the angle bisector equation. So you're going to have 15 over x. Okay, it's going to equal to 20 over y. Okay, so again, it's very simple. This over this equal to this over that for angle bisector. We also know that x plus y equal to 10. So from here we can go and solve. So let's go ahead and so move this over, and then we can substitute. Now you can do it this way, or you can actually find the ratio of x. You can find it from here and substitute into here. So either way. So if you cross multiply, you get when you cross multiply, you get 150 minus 15y equal to 20. Oh wait, what am I doing? Time out. X. Okay, so substitute here. So you got 10 minus y. There we go. Okay, so if you cross multiply, cross multiply, you get 15y equal to 200 minus 20y. There we go. So move this over, so you get 35y equal to 200 divided by 35 divided by 35. So y will equal to, if you simplify this by 5, you get 40 over 7. And you can look for x. So from here, x equal to 10 minus y, so it'll be 40 over 7. So x equal to 70 over 7 minus 40 over 7. So x equal to 30 over 7. Okay. So the longest segment would be this one here. So the longest segment would be 40 over 7. Okay, let's go to number 170. Okay, 170. What is the number of distinct lines represent the altitude, median, and interior angle bisector of a triangle that is isosceles but not equilateral? Okay, so if you have isosceles, okay, and so you want to draw, okay, represent altitude. So if you, so the altitude, okay, so let's do the altitude. So you can have altitude is to the perpendicular, it's from vertex to perpendicular of the other side. So that's one altitude, and that's 2, that's 3. So the altitude you're going to get 1, 2, 3. Okay, now let's do the median. The median is drawn to the midpoint. Okay, so from here. Now this is also a median, so you don't get a new one. Okay, so from here you can draw. I'm going to use a different line, different color. Okay, so this is your median. So 1, 2, and over here this coincides with that. So you only get 2 new lines. Okay. And the angle bisector, when you bisect the angle, so this is also the angle bisector, so you don't get a new one. Okay. Now, when you bisect the angle, you can get this one here, and you can bisect the angle. Okay. So this one you also get 2 new ones. So because the isosceles triangle, this line is for altitude, median, and also angle bisector. Okay, so you only get total of 7 distinct lines. Okay, let's go to number 171. Okay, so triangle ABD is a right angle at B. Okay, so let's draw a So right triangle is right angle at B. And on AD, so ABD. So triangle ABD is right angle at B, and on AD there's a point C. That's a point C for which AC is equal to AD. And AB equal to BC. Okay, so AB equal to BC. Okay, find angle DAB. Find angle DAB. So you're looking for this theta right over here. Okay, so what you need to do is you need to go and draw this over here. Okay, now because this is a right angle, if you imagine if you were to draw a circle, okay, Okay. So if you draw a circle, okay, this would be the radius. So again, the hypotenuse, the midpoint of a hypotenuse is equal distance to all three vertices. So this would be also equal. Okay. So again, all these three are equal. But notice the given is that this is equal to that. That means all these are equal. So this is an equilateral triangle, and therefore theta equal to 60 degrees. Okay. So this is a very important theorem. Okay. The midpoint of the hypotenuse of the right triangle is equal distance to the three vertices. And you're going to use this theorem a lot. So you need to remember that. Okay. So again, all these are equal, and since this is equal to that, so all three sides are equal, so this is equilateral triangle, and therefore this will be 60 degrees. Okay, let's go to 172. Okay, it says the triangle PYT is a right triangle. Okay, so let's be through first. Triangle PYT is a right triangle in which PY equal to 66, YT equal to 77. Okay, now it says PT is more than 50 and it's expressed in a simplified form x squared of y, then find x plus y. Okay, so you don't know which is hypotenuse. Okay, so you got two situations. So let's say if you have this situation, let's say 77 is the hypotenuse, and this is the leg, and the other one is also the leg. Okay, so this one is the x squared of y. Okay, so if you have this kind of situation, if you use a Pythagorean theorem, okay, so and the way you're going to do that is, again, you're going to have the 66 and x squared of y and 77, right? So factor out the 11, you get 6, and I'm going to call it z and 7. So use your Pythagorean theorem. Okay, so 6 squared plus z squared equal to 7 squared. 36 plus z squared equal to 49. So minus 36 minus 36. So z squared equal to 13. So z equal to square root of 13. Therefore, xy will equal to 11 square root of 13. Okay. Now we have to check though, because the side had to be, so the length had to be greater than, it's more than 50, right? So you have to check. So 11 square root of 13 is about 11 square root of 16. Okay, if you use calculator, you can just figure. But if a lot of time in computation, you don't have a calculator, right? So this is about 11 times 4. Okay, it's about 44. So this one does not fulfill that. Okay, so this is going to be wrong. Okay, so that means this cannot be the leg. This has to be the hypotenuse. So we have to look at the other way. Okay, so this would be the x squared root of y, and this would be 66, and this would be 77. So again, this cannot be the leg. This has to be a hypotenuse. If it's a leg, it's going to be too short. Okay, because it has to be greater than 50, right? So again, the length has to be greater than 50. Okay, so again, let's go and figure this out. So you can factor out the 11. So make things a lot easier to do. So use your Pythagorean theorem. Okay. Okay, so z equal to square root of 85. Okay. And once you do that, and then this would be just multiplied by 11, so it would be 11 square root of 85. Okay. And so from here, now you have to check, is this greater than 50? Okay, well, 11 square root of 85 is approximately a little bit greater than, this is about 11 square root of 81. So about 11 times 9, so it gives you about 99. Okay, so this is greater than 50, so this checks, so this is good. Okay, so once you do that, you can see that x equal to 11, y equal to 85. Okay, so x plus y will give you 96. Okay, and that's your answer. Okay, let's go to 173. It says if triangle PQR has sides of 40, 60, and 80. So you got 40, 60, and 80. Then the shortest altitude is K. Okay, so now the shortest altitude would be the altitude to the longest side. Okay, so this would be your x. Okay, so the shortest altitude is K times the longest altitude. So the longest altitude would be this one here. Again, so the altitude to the shortest side would be the longest. The altitude to the longest side would be the shortest. Okay. So the shortest altitude equal to K times the length of the longest altitude. Okay. And so from here you can see that K equal to x over y. Okay. Now you're looking for the value of K. Okay. So to find value of K, you need to find x and y, right? Okay, so what you need to do is, whenever you deal with altitude, you should think about areas, okay? So the area equal to 1/2 the base times the height, okay? The altitude is the height, right? And this is also equal to the area. So if you look at triangle this way, it's 1/2 base times height. If you turn a triangle around, it's also equal to 1/2 the base times the height. Okay, and so from here you can just get rid of the a, right? And then you can go ahead and solve. Okay, so you can see that this will cancel out, right? 1/2 will cancel out, and you're looking for x over y. So you can divide by y. So you got 80x over y equal to 40, right? Then you can divide by 80, so this cancels out. So x over y equal to 1/2. So you don't have to kind of actually solve it by itself, okay? And so that's it.